Welcome to Spring Lib.
In this problem, we have been given that there is a skateboarder, and that skateboarder goes down the ramp starting at this point E. So, as the skateboarder is starting at this point E, it will have 0 meter per second as its initial velocity, and this follows this curved path as indicated here, which is a part of the circle of radius 5 meters. And we need to determine here the speed with which the skateboarder is leaving the ramp. So let's consider that speed to be v, which is what we need to determine here. And all these respective angles and the radius is provided here. Here this point C, that's at the zero potential, that's the gravitational potential energy is zero at that point, and a constant resistive force of 10 newton is provided. So here we need to determine, by considering no friction force and a constant resistive force, with what speed the skateboarder is leaving the ramp here. So let's apply the energy conservation. So first we can see here that at point E, the total energy is only because of the gravitational potential energy, and that's mass times acceleration due to gravity times the vertical height. So we can determine the vertical height by using the knowledge that it's the radius of the circle. So that will be 5 times mg, and this total energy gets converted into the gravitational potential energy at this point B, as well as the kinetic energy, and even it includes the energy which is lost in order to overcome the resistive forces. So here the gravitational potential energy, it will be mg times h. Let's consider h as the vertical height here, plus half mv squared, that's the kinetic energy at this point, plus the energy that is dissipated because of the resistive forces of 10 newtons. So for that, let's get the idea about this total length. So we'll multiply the resistive force with the total length. So here we observe that the total angle is 90 plus 40, that's 130 degree. And the total length, let's consider as L. So L can be determined by using the idea that 130 degree upon 360 degree times the total arc length, which is 2 pi times the radius, which is 5 here. So simplifying this, we're going to get 130 upon 360 times 2 times 3.14 times 5. That comes out to be 11.34 meters. And the value of h will be the projection of this radius, which will be OD, which is 5 times cos 40 degree, and this has to be subtracted from the total radius. So here when we subtract 5 cos 40 degree from 5, we're going to get here the vertical height as 1.17 meters approximately. So let's put all the values here, and we're going to get 5 mg is equal to mg into vertical height, that's 1.17 times gh. H is already we have substituted, so m will remain here, plus half mv square plus 50 times L, that's 50 times 11.34. And also here we have been given the total mass of the skateboarder, including the skateboard, is 50 kg. So let's substitute M as 50 kg here. So we're going to get 5 times 50 times G minus 1.17 times mg, which will come out to be approximately 1876.7, and that's equal to 25 v square plus 50 times 11.34, that's 567. So from here we subtract 567 from 1876.7, and we divide it with 25, and further we take the square root of the value, and that's going to get us approximately the speed coming out to be 7.24 meter per second.